Now that we have discussed about Euclid's contribution to understanding the geometry in his own mathematical understanding in historical facts, let's see the most important concept as contributed by Euclid, called Euclid's postulates. There are 5 postulates which are recognized in the branch of mathematics and are found to be very helpful in mathematical understanding. So let's see the 5 Euclid's postulates, the contribution of Euclid in geometry. Euclid's postulates. Each postulate has its own understanding which helps us in understanding various geometrical properties involved in real life situations. So coming to Euclid's postulates is the topic of the session. To start with, postulate number 1. Postulate 1. So what was Euclid's postulate number 1? Postulate number 1 states that if I take any 2 distinct points in the plane, randomly any 2 distinct points taken in the plane, then Euclid's postulate number 1 says that there's only one and unique line which passes through those 2 points. You cannot have more than one line which passes through. So here the postulate number 1 says, given the 2 distinct points one and only one line can be drawn passing through them, that is, passing through the 2 distinct points. So postulate number 1 clearly says, given the 2 distinct points, one and only one line can be drawn passing through them. This is one of the most important invention during those times in history. We are applying the concepts in the modern times, but everything has originated from the Euclid's postulates, his contribution to geometry. So let's see the statement in brief, the postulate number 1 in brief. The postulate number 1 says, given the 2 distinct points. So let me take the 2 points which are distinct in the sense they are not same from each other. They are different from each other. So given that there are 2 points which are different from each other, then Euclid's postulate number 1 says that there is only one line which can pass through them. It's very clear that when we take the ruler and try to draw a line joining the 2 points, obviously you have only one line which can pass through them. You cannot investigate on trying to draw another line passing through the 2 points. Is how Euclid has contributed through postulate number 1. Given the 2 distinct points A and B, there's only one and unique line which can pass through them. So according to postulate number 1, this is called the unique line through A and B. So here the line which I draw through A and B is the unique line, that is, note there cannot be any other line which can be drawn there cannot be any other line which can be drawn through A and B. This is the only line which can be drawn through A and B, is how I understand the postulate number 1. Given two distinct points, there's only one line, a unique line which can be drawn through A and B. No, more than one line is not possible according to Euclid's postulate number 1. Euclid and his postulate number 1 contributed to the mathematical society. Now that we have learnt about postulate number 1 as contributed by Euclid, let's now see what postulate number 2 states in its own definition. Postulate number 2. Now, before we get into the postulate number 2, we all know what a line segment is. In the modern times, we have been discussing about a line segment, what Euclid has called during his times as a terminated line. So as we take, let's see the definition and then get into understanding the concept by taking an example situation. A terminated line can be produced indefinitely. So here the postulate number 2 says a terminated line can be produced indefinitely. So what does this mean? A terminated line is the term which in modern times is referred as the line segment. We all know what a line segment is. The line which has ends towards the right and the left. Suppose I take a line segment AB. So here is my line segment. So my line segment is connected by the points A and B. So the terminated line is the line which ends on either side, is what Euclid has defined in his own terms. So in terms of line segment, the line which ends on both sides can also be produced according to Euclid. His postulate number 2 says that a line which ends at 2 points can be extended on either side and also can be extended onto this side, so that this line can be a straight line which can indefinitely be extended on the right and the left. So this line goes till plus infinity on the right and minus infinity on the left, is what we have learned in the real number line. So a terminated line can be produced indefinitely on either side of its terminated points A and B, so that we get an infinite line, or it can be produced indefinitely, is what is postulate number 2 defined as Euclid's contribution to mathematical society using the postulate number 2. A terminated line can be produced indefinitely. Now let's enter into postulate number 3. The postulate number 1, postulate number 2, and now to come with postulate number 3. According to Euclid, his contribution to postulate number 3 was more focused on a circle. As we have seen, a circle with center and radius. So Euclid has investigated on the circle with its center and radius, and hence has come out with postulate number 3. Postulate number 3, as derived by Euclid, dedicated to the circles, the radius and center. So let's see what the postulate number 3 states. A circle can be drawn with any center and radius. This is what the postulate number 3 states. A circle can be drawn with any center and radius. So this investigation, clearly as evident on recognizing the different circles, was what has come out with the outcome of postulate number 3 by Euclid. As we can see, let's start with a circle. We know that when you take a fixed point and take a compass and just rotate it, I get a sort of a circle out here with the center here. Let me take the compass with a more bigger region and then I get the circle. Let me now take a very small region of the compass and then try to rotate. I get the circle. So here I have circle 1, circle 2, and circle 3, which have their respective radii. So each of the circles have their own radii in this case. So Euclid says that any circle can be drawn provided we have the fixed distance between what we derive the circle as. So according to Euclid, a circle can be drawn with any center and radius. This is with a center and a radius, and this is with another center and another radii, and this is with different center and radii. All three are circles. All these three are circles. So any circle, however big or however small, can be drawn with fixed center and radius, is what the postulate number 3 states according to Euclid's contribution to mathematical society. Next comes postulate number 4. Now Euclid is known also for recognizing or investigating many mathematical properties in right angle triangles. Just like Pythagoras has been investigating, Euclid has also contributed a lot on the right angles. The student of Thales, Euclid, has come out with his own contribution to the mathematical society. So let's see what the postulate number 4 contributes through the right angles. So the postulate number 4 says that all right angles are equal to one another. This might look very silly in the modern times, but it's very important that during those times where mathematics was very limited to its own knowledge was a very great invention, as with the postulate number 4 by Euclid. This is to be taken into mind very seriously. So postulate 4 says all right angles are equal to one another. Let's see how we can justify the statement. Let me take a right angle which is measured out here between the lines L2 and L1. Let me take another situation where I have a right angle, that is I have here between the sides BC and AC. Let me take one more situation where I have a right angle. For example, I have a circle or I have one more circle property which says angle in a semicircle is 90 degrees. So in this case I have four cases of right angles, where in this case I have the line L1 which is exactly at 90 degrees. Usually 90 degrees is denoted by this symbol square. So this represents angle 90, is how I understand the 90 degrees concept. Similarly, I have triangle ABC in which angle C is 90 degrees through the sides BC and AC. Next, I have a circle in which at this point P, the tangent is set to make 90 degrees with the radius. This is the radius of the circle and this is the tangent, and at the point the tangent is set to make 90 degrees with the radius of the circle. Similarly, I take a circle which passes through the center of the circle, then this is called angle in a semicircle which is 90 degrees. So this is how I justify the property. In a semicircle, angle is 90 degrees. So in each case we have 90 degrees, which is different in different situations. But according to Euclid's postulate number 4, Euclid says all right angles are equal to one another. The 90 degrees here must be equal to the right angle which is 90 degrees here, must be equal to the right angle which is equal, or the 90 degrees in this case, all these four right angles are said to be equal in their own respective manner. So according to Euclid's postulate number 4, all right angles must be equal to the other, however different they are in their own geometrical situation. They are right angles, they must be equal. Now let's see the postulate number 5, the last postulate in Euclid's contribution. Postulate number 5. Now coming to the postulate number 5, before we discuss its complete definition, let me tell that all the 5 postulates are dedicated to Euclid, but the first 4 postulates are very simple to understand because they are self-evident. We can analyze, obviously, when I say all right angles are equal to one another, that means 90 degrees, it will be same anyway. So they are not that much focused on, but the 5th postulate, which is very complex, is how Euclid has contributed to developing the geometry as ages pass by. So let's see the postulate number 5 contributed to geometry. According to Euclid, if there are 2 lines out here, and then if there is another line which cuts this with interior angles being, say, this is x and this is y, then if x plus y is less than 180 degrees, according to Euclid, this was referred as 2 right angles. So according to Euclid, if some of these 2 angles formed by the line, so this is P and Q, if this is the line PQ which makes the angles x and y in the interior angles on same side, say for example, if I take on the left side of the line PQ, the interior angles are x and y and the exterior angles are the one which are outside. So when I take the interior angles x and y, the condition is if x plus y is less than 180, then the postulate number 5 says the line PQ cuts the other two lines L1 and L2, and obviously in this case here they cut at P and Q is how I understand the postulate number 5 as connected with intersecting lines. So with the condition that the two interior angles on the same side of the line being less than two right angles, that is one right angle is 90, so two right angles make 180 degrees. So we call 180 degrees as two right angles. Then if the sum of interior angles is less than 180 degrees, then the line PQ, as clearly can be seen here, cuts the other two lines L1 and L2 obviously at P and at Q, is how we understand the postulate number 5 as contributed in the mathematical society by the great mathematician Euclid. Today's session is about postulates. The Euclid's postulates is what we are going to define or discuss more of in today's session. So let's see what are postulates. So the contribution of Euclid's postulates, but before that we will try to see what exactly the word postulate means in mathematical understanding. Before we discuss in brief about Euclid's postulates, the 5 postulates as contributed by Euclid in the mathematical society, let's define what a postulate is. What is a postulate? The term, which looks very complex in mathematics, has got a very wide definition and which plays a very important role in the benchmark of geometry. Postulate means making a statement on observed phenomenon. Postulate generally means making a statement on observed phenomenon. Its proof, its truth and validity is then checked later on. So here I have these two important things which are interlinked and defines a postulate. It's very important to understand a postulate in mathematics before we get into understanding geometry. So in mathematics, it is assumed that there are many proofs or theorems or many axioms or many postulates which have been invented or discovered by the past mathematicians. So here the postulate is defined to be making a statement on observed phenomenon. So generally when I make a postulate, it is about that I don't prove it, but I just make a statement on observed phenomenon. Just like I point out in the student, if a student is consistently talking in the class, then I rate him as a talkative person. This is the statement which I make on the observed phenomenon during the class session. In the similar manner, when I observe certain mathematical properties, it to be true in all times, then I say this will be true forever, and hence it's a postulate. To continue with this, its truth and validity also plays a vital role. When I say that I make a statement, I'm not going to make it unjustified. When I say the student is talkative, I'm not just cursing on him or I'm just not taking revenge on the student. It is because his behavior in the class is talkative, I point out saying, you are talkative. So similarly, when I justify on whether the statement which I'm making is correct or wrong, I try to justify it on later on by applying that into the situation. Let's take an example problem to understand the postulate more better. Imagine I have 2 points which are distinct and very far away. Now I take a ruler and I try to draw a line passing through them. So when I take the ruler and just try to draw a line, I just see that there's only one line which can be drawn. So for these two distinct points as taken on the plane, let's see how we can connect this with a postulate. Imagine the two distinct points A and point B. Now let me just investigate on a property which can be invented or derived from this investigation of two distinct points A and B. Now for these two distinct points, I would like to see how many number of lines I can draw. So I try to make an attempt in drawing this line which doesn't pass through the points. Then I make an attempt to draw a line passing through this and attempting to make this line pass through the other one. This also does not pass through the other line. So with this investigations, I wonder to see, is there any line which can pass through the 2 points, and how many such lines can be passed through that 2 points. So as I see here, I come across a line which is set to pass through A and B. Now out of the different lines I have taken, I recognize that there is only one line which can pass through these 2 points. Or out of all the different possibilities of different lines I take, I see that there's only one line which passes through A and B. So I make a statement through my observed phenomenon which says that there's only one line which can be made to pass through two distinct points. Then that makes my statement, which is on the observed phenomenon. Now comes its truth and validity, which is checked later on. So I take the plane, I plot the points, the two distinct points, and then try to make different lines possible. Then I check through the validity that yes, there's only one line which can pass through the 2 points, and hence it is called a postulate. Similarly, I take a point and I want to see how many lines are possible to be drawn from this point. So I investigate with 1, 2, 3, 4, 5, 6, etc. So different lines pass through the point. So I make the statement that there are infinitely many lines which pass through that point. So my postulate is about making a statement on observed phenomenon is that infinitely many lines pass through the point on observed phenomenon. And I check through the truth and validity. I draw the different lines and I see that there are infinitely many lines which pass through the point. Is how the postulate comes. Truth and validity check out, and only if it is true we call this as a postulate. If my truth and validity, which is checked later on, does not prove the made statement, then it cannot be a postulate. We cannot call that a postulate. Postulate is a statement made on observed phenomenon. Its truth and validity checked later on. If the truth comes out to be universally true, then the statement is a postulate. It must be called a postulate. Euclid's postulates to be followed with. Euclid's postulates. Now that we have seen the 5 different postulates in Euclid's contribution to mathematical society, now comes what are the uses of these postulates? Where do we use them? What are the significances of the 5 postulates as we have learned in the previous session? Is the biggest question which arises next. So Euclid's contribution is about his postulates which are applied in different axioms, theorems, or various properties in mathematics. So let's see few of the properties in mathematics where Euclid's postulates are exclusively used in deriving those properties. So here comes the topic applications of Euclid's postulates. So let's see the different applications of Euclid's postulates in brief. As we have seen the different 5 postulates, let me come with this property. Say I have a line segment which is divided at A, at B, and C divides the line AB. So in this case, I clearly see that the distance AC and the distance BC when added gives me the distance AB. Therefore, the property says the distance AB, the distance AC plus the distance CB is equals the distance AB, is how I derive using the Euclid's postulates. The postulate which says between 2 distinct points there is only one line which can be drawn, and therefore I have only one line which passes through A and C, which are the distinct points, and there is only one unique line which passes through C and B, which is unique, and therefore this will be a complete same line which passes through all the 3 points. You cannot draw more than one line passing through A, C and B taken in pairs as distinct points, AC and CB. So this postulate number 1, as we have discussed in Euclid's postulates, we have a property which says the sum of 2 sides is the sum of the longer side. That is, AC plus CB will be equal to AB, is how the property gets derived using the Euclid's postulates. Significance of Euclid's properties or Euclid's postulates in the branch of mathematics. Property AB plus BC will always be equal to AC if the 3 points A, B and C are on the same line as given here. A, B and C are on the same unique line. Cut. Let's see one more mathematical property which has used Euclid's postulates in its own derivation. So as we say, Euclid has used his postulates to prove that an equilateral triangle is a triangle which has all 3 sides equal, as we know. An equilateral triangle can be constructed or derived from any line segment, is how we understand the postulate. An equilateral triangle can be constructed or derived from any line segment. So let's see how we use the postulates in this. So Euclid has come out with taking a fixed line segment AB with terminated line, as he used to call during his times. He has taken a terminated line AB and then tried to construct an equilateral triangle using this dimension AB. Therefore, he has come with the measurement and then used the circle property to construct an equilateral triangle from a line segment. The circle property as he has defined that any circle with any radius can be formed. A circle can be formed simply by taking different radii and different centers. Therefore, he has taken a circle fixed with A and then cutting an arc. So he has made a circle passing this way. And then from this B as the center and AB as the radius, he has cut another circle out here. So there are two circles which are formed out here, cut. Now this point of intersection was taken as a third coordinate C. The two circles derived cut at one point of intersection, which is called the point C. Now as you join this and as we join this, we get an equilateral triangle. An equilateral triangle which has all the three sides equal is how Euclid has come out with any circle can be drawn with center and radius. So he derived different circles within the line segment and then the point of intersection was joined to form triangle ABC is constructed equilateral triangle because AB equals BC equals AC. So triangle ABC is constructed equilateral triangle. Equilateral triangle with all three sides equal. So in this manner, any line segment can be taken to be just intercepted and I get an equilateral triangle. I take another line segment which is smaller in size. I use the same concept of cutting the arcs and then I join to get an equilateral triangle. Or I take a very big line segment, cut an arc with the respective length of the line segment as radius and the point where the two circles intersect, I join the other two segments and I get an equilateral triangle. An equilateral triangle can be constructed from any line segment is how we understand the postulates of Euclid applied in real life situations. Constructing an equilateral triangle from a fixed line segment out here. Now let's see the theorem. Let's see how Euclid has proved a theorem using the 5 postulates which he has used in his contributed life, which he has invented in his contributed life. So let's see how the postulates have been useful in exclusively proving a new property through the contradiction. So let's see the property. To start with, Euclid's postulates helpful in deriving a theorem. So let's see how a theorem is derived using Euclid's postulates exclusively. The theorem says two distinct lines cannot have more than one point in common. So the theorem here says when I take two distinct lines, those two distinct lines cannot have more than one point in common. That is, the theorem says if I take two distinct lines which are not same, then when they are extended, obviously they have to meet at one point. So here, when this lines AB and CD are extended, then these lines meet at one point. They have one point in common, or they have one point of intersection. They must intersect, provided those two lines are not parallel to each other. So two distinct lines cannot have more than one point in common is how I understand the two lines intersecting. There should be only one point of intersection possible. So let's see how this theorem has been proved exclusively using the postulates. So the proof is by contradiction. Like, given the statement, I take the contradiction of the statement and then prove that the result of that contradictory statement is not true using the proof. So now it is given that the two distinct lines cannot have more than one point in common. I take this to be line 1 and this to be line 2, and I assume that let the two lines which are distinct have more than one point in common. So cannot is now contradicted to be can. Let's contradict the statement that is, let the lines L1 and L2 have more than, or I can say have more than one point. That is, 2 points, 2 points in common. That is, the two lines are said to be intersecting at P and Q. Therefore, let L1 and L2 intersect at, say, at P and Q. Let L1 and L2 intersect at P and Q. Now, here comes the concept of proving the theorem. Now that we have assumed that the lines L1 and L2 intersect at P and Q, therefore, but this is not true. Why do you think that this is not true? Because we have already seen in the postulate that there's only one line which passes through the 2 points. Now here I have 2 points through which it is assumed that there are 2 lines which are passing through L1 and L2. So here in this statement it is assumed that there are lines L1 and L2 which pass through P and Q, which is not possible, or it contradicts the statement, the postulate number 1. The unique line, there's only one line, one and only one line which passes through 2 distinct points. But here the distinct points P and Q, but there are 2 lines passing through the same point. So this contradicts postulate 1. Therefore, our assumption is wrong. What is our assumption? Our assumption that the lines L1 and L2 have more than one point in common is true, is false. So our assumption is wrong, implies the original statement is correct. So this kind of proofs are called proofs by contradiction, where I take the contradiction of the given statement, the distinct lines cannot have more than one point in common. Let's take the statement two distinct lines have more than one point in common and then prove by contradiction. So contradicting the statement L1 and L2 have more than one point in common. Say I have the lines which are intersecting at 2 points, or they have 2 points in common. So we have L1 and L2 intersecting at P and Q, say for example. But this is not true, because a line, there's only one and only one line which passes through the distinct points P and Q, but we have two lines which are passing through P and Q, and contradicts postulate number 1 as discussed in the previous session. Therefore, our assumption is wrong. Therefore, the original statement is true. The original statement is true. The original statement which says two distinct lines cannot have more than one point in common. If the two lines which are distinct at the most can have one point in common, but not more than that. You cannot have 2 points of intersections for this lines intersecting. As we have already seen in the linear polynomial, the two linear polynomials intersect at only one point. This is how we connect the learned concepts in mathematics to Euclid's postulate and Euclid's contributed theorem. Theorem applied through postulates and proved mathematically.